Hey there, everyone. Welcome to your first asynchronous lesson. All right, so our asynchronous lessons will almost always come with some short PowerPoint or Google Slides, whatever you call it, and a note sheet. So it's a way for you to kind of narrow down what content to focus on and what we're going to apply in class together. So this video, hopefully going to be short and sweet. Fill out your notes while you watch it. I'm going to be explaining things as we go. The basics are going to be in your note sheet, but I'm going to add a little more information too. So feel free to listen and take extra notes anywhere you see fit. So today we're going to be talking about the layers of the atmosphere. Boom. What does it mean for something to be layered? So there's a spot in your notes where it asks for you to kind of write your own definition. Now you can do this before you see the answer on the next slide. That's what I strongly recommend. Or, you can modify your answer after you've already, written your original response. So the original question, what does it mean for someone to be layered? Right? Maybe you've seen the movie Shrek. Yeah. Parfaits have layers. Ogres have layers. But what does that mean? So take a second, think about what this means to you. Pause the video if you need to. What does it mean? So what does it mean for someone to be layered? Boom, layered. It means it can be separated into different sections and pieces. So it means it can be divided up, and each section and piece is distinguishable from the one next to it. So that means that it can be separated, like this piece is different than that piece is different than this piece. Often composition is the way to tell these layers apart. So composition is just what something is made of. So there's a wide variety of things. Humans are made of cells. Cake is made of sugar, flour, other stuff, eggs, right? Oil, all sorts of things. But composition is just what is something made of. And that's often how we tell different layers apart. So can you think of some examples of what it means to be layered? Like a layered cake, maybe? Yeah, delicious. Skin, yeah, maybe not quite as delicious, but definitely helpful and definitely layered. The earth, right? We just finished that unit. And of course, the atmosphere. That's what we're studying right now. So here's an example of a layered cake, right? You can see each individual layer because it's made of something different. It looks a different color because it has a different composition. My goodness, does it look delicious. If we talk about our skin, the skin actually has 3 layers. It's got an epidermis, a dermis, and a subcutaneous tissue underneath it. And each layer has a slightly different composition, allowing it to serve a different purpose. The layers of the earth, right? We just had a whole test on that stuff. And each layer is made of different things, or it has slightly different compositions. Maybe it's a rocky layer that's rock hard. Maybe it's a rocky layer that's a little hotter, a little more plasticky. Different features, right, due to the compositional differences. And then you have your core, which is made out of iron and nickel, sometimes solid in the inner core, and sometimes liquid in the outer core. So this is one way that we tell layers apart from each other. And this isn't any different in our atmosphere. So the layers of the atmosphere, the troposphere, stratosphere, mesosphere, thermosphere, exosphere, those are all also distinguishable from each other due to various features. So how do we divide these different layers, right? A, the layers of the atmosphere are divided based on temperature and composition. Those are the 2 main ways that we tell them apart. Basically, what we see happening in each layer is that the temperature's changing and the composition's changing, and they're directly related. When the composition changes, that causes changes in temperature. Most of the atmosphere is made of just 2 gases. If you remember that what's in the air assignment that we did, most of the atmosphere is made of nitrogen, about 78%, yeah? And then we have oxygen, about 21%, right? That's a wide amount of the atmosphere. 99% is just those 2 gases. And then the last 1% is made of trace amounts of other gases. It's mostly argon. We've got carbon dioxide, you've got carbon monoxide, you've got methane, water vapor, ozone, and all sorts of other minor things that can be found in our atmosphere. It is the pressure and the gases that make up the smaller percentage of our atmosphere that cause temperature variations in the layers of the atmosphere. All of the layers of the atmosphere have nitrogen and oxygen, but it's that tiny amount of different gases that cause these massive changes in temperature and features. Not to mention pressure, right? The higher you go up, the pressure is going down. So the layers of the atmosphere names, they're all going to sound somewhat similar because they all end in the word sphere. And that's because they're like three-dimensional circles. They encompass our planet, which is indeed round. So each layer ends in the word sphere. Each layer has changes in temperature due to composition and pressure changes. Again, we're seeing a change in features which causes us to tell these layers apart. That's what makes them layered and distinguishable from each other. So each layer that we have here has prefixes. They all end in the word sphere, but they start with different words. If we look down here at the troposphere, so troposphere, the prefix tropo means turning. And that's because this is where all of our weather is. The air's turning over. It's causing our weather. It's causing all sorts of stuff. And that's our troposphere. The way I remember it's the first layer is it's on top of us, right? So the troposphere, for sure. The stratosphere is a layer above it. And strato in Latin means layer. You might remember stratified layers of rock. Strato means layered. And that's because it has a layer of ozone in it. That's where that name comes from. Mesosphere is our next one. You notice it's sandwiched right here in the middle. And that's exactly what meso means. Meso in Latin means middle. Anytime you hear the word meso at the beginning of a word, that means middle. Yeah, and that's where it's at. Thermosphere is above that. And thermo, you might remember a thermometer. Actually, it's heat. Yeah, a thermometer measures heat. The thermosphere is like a heat sphere. Yeah. So the layers of the atmosphere names, there's also in between each layer, you'll notice in this beautiful picture over here, that each layer kind of has an ending, right? Now, in reality, there's not an invisible line that divides each layer. You can't fly up in an airplane and all of a sudden hit this random line in between the troposphere and stratosphere. However, there is a location in our atmosphere where the composition starts to shift. And that area is marked by an imaginary line called a pause, right? So pause. And that just means that layer is stopping. So for example, the top of the troposphere, right in between the troposphere and stratosphere, that's the tropopause, because the troposphere pauses there. It's not going any further. So if you ever hear the word tropopause, that's the top of the troposphere. Stratopause is the top of the stratosphere. Gosh, look at these names. We're just flying through them. So let's talk about each actual layer, right? Because each one has unique qualities. We're going to start with the troposphere because it's on top of us. It's right there. This is from 0 to 12 kilometers. It's the smallest layer and it's the closest to the ground. Now this is where all of our weather occurs. It's where all life occurs. And 90% of Earth's air is found at that layer. So you have the highest amount of pressure all the way down here. And that's because gravity's pulling everything down. All of the air is stacking down in this layer. So even though it's the smallest, it has by far the most air of the entire atmosphere. 90% of the Earth's air. Instead of being warmed by the sunlight from up above, it's actually warmed from below. And we're going to look at that more next week. So it's warmed by the ground. And as you get higher and higher up, the temperature drops. It gets colder and colder because it's getting away from that heat source, which is the ground in this layer. As it gets higher, the pressure gets colder. And of course, another fun fact, we live here. Yeah, all life on our planet is found in here, except for the very few people who are on satellites right now. The stratosphere, that's our next layer. Now, as we go higher and higher up, remember gravity's pulling a little bit less. So we've got a lower pressure in this zone. But what we notice, even though we have a lower pressure, the temperature actually starts getting hotter and hotter, which kind of baffles people at first, right? Why would it start getting hotter? Well, that's because it has a layer of ozone in it. And that ozone absorbs energy from the sun. It's taking in those ultraviolet rays. And we need this layer to trap heat. Without it, Earth would become a frozen ball in the middle of space. We have to have that ozone layer. So strato means layer. It has a layer of ozone in it. Finally, the mesosphere. This is from 50 kilometers to 80 kilometers. Again, as we go higher, gravity's lower. We have lower pressure. And we notice that we start seeing a drop in temperature again in that mesosphere. And that's simply because the composition changed. We don't have any ozone in the mesosphere. So the stratosphere got warmer because of the ozone. Mesosphere, no ozone, therefore it's going to become the coldest layer of all. It gets crazy cold. And even though there isn't that much air, you know, the pressure's pretty low, this is where we get our meteor showers. So when you see meteors burning up in the atmosphere, this is the layer where that typically happens. Yeah, and that's because there's enough pressure still to burn up those meteors. We'll talk more about that when we talk about our layers of the atmosphere analysis questions. Finally, the last layer is 80 kilometers all the way up to 600 kilometers. This is a huge layer. It's the outermost layer, the thermosphere that is, and it's also the hottest layer. We'll talk more in class with our analysis questions for what exactly this means to be the hottest layer. But if you measure the individual molecules, boom, we see it off the charts temperatures. And that's because you have really high levels of solar radiation in that level. You're closer to the sun, and you have higher energy levels up there. This is where most satellites hang out. Actually, the International Space Station, most of the satellites that you hear about are still technically within our atmosphere. They're technically in that thermosphere or exosphere, which I think is just kind of cool. So when they say they're in outer space, I mean, they're still in our atmosphere, which is pretty cool. This does have the lowest pressure layer. So those are our 4 layers of the atmosphere. We have the troposphere, which is on top of us. We have the stratosphere, mesosphere, thermosphere. Those are the 4 main layers. The layers are divided basically by temperature. That's like the main way we tell them apart. Temperature changes are caused by changes in pressure. And, oh, this says temperature, but it should say composition. So pressure changes and composition changes cause these temperature changes. You can use this note sheet and the under pressure activity from in class this week to help you review for your vocabulary quiz next week. You will have a vocab quiz on terminology from the under pressure activity, and one other activity from next week. So just keep that in mind, vocab quiz, make sure you're reading through your notes, reviewing, and making sure you're staying on top of things. Thank you very much, everybody. I hope you have a wonderful week.